not supposed to be done.
Hi. I'm trying to pull out my pens so we can type. There they are. Actually, not type, but draw. I made a video earlier and it disappeared, so I'm making another one. Okay, so here we go. So, based on the conversations that we have had, it seems like the quadratic formula is working best for you. So I'm going to do all of these first problems using the quadratic formula. Okay, so the first thing we're going to do is decide what A, B, and C are. So A is 1, B is 1, C is negative 12. And I'll go ahead and write the generic form of the Pythagorean, sorry, not Pythagorean theorem, the quadratic formula, so that you can just see it, and then we'll always be filling that in, of course. So big thing, remember that your B always has to go in as the opposite sign. So RB is positive, so it's going to go in as a negative. This equals negative 1 plus. So I'm just going to write the plus version down, knowing that your minus version is the exact same thing, you just change your sign. So it's 1 squared minus 4 times 1 times negative 12. All over 2 times 1. So I'm going to plug it in and then I'll turn it around and let you see it. So you can see what I've plugged in, and if yours isn't working quite the same, we can compare. Okay, so here is what I have plugged in. And so when I hit enter, I got 3. So now I'm going to do the exact same thing, just change my plus to a minus after the negative 1, so that's going in as a minus now. So that's negative 4. Okay, so that's the answers for that one. Okay, so A is 2, B is negative 14, C is 37, so opposite of B in this case would be a positive 14. The other thing here too, because B is a negative number, we have to make sure we plug it in as in the parentheses. Otherwise the calculator will do it wrong because it doesn't know what we mean, it just knows what it sees. So it's 4 times 2 times 37, all over 2 times 2. So here's what it looks like. So I got 3.5 plus 2.5j. So this one has an imaginary number. Remember we switched the i's off the calculator to j's. The calculator is using everything that's in theory, where we're in application class, and in the real world we use j. And imaginary numbers come in pairs, so you don't even need to take the time to do the minus sign. All you need to do is just also do a minus sign here, because they're always in pairs. One's a plus, one's a minus. Okay, so we're going to C. A is 1, B is negative 1, C is negative 2. So opposite of B, so we're going positive plus negative 1 squared minus 4 times 1 times C. That's a times, not a decimal. 2 times 1. So I'm going to plug that in. 1 plus the square root, parentheses, negative 1 squared minus 4 times 1 times negative 2 over 2 times 1. Here it is plugged in. So the first answer I got is 2.
I didn't.
So I'll go ahead and do the minus. And I got a -1. Okay, D is a little bit different because D is missing a term. So the key here is to make sure you know which one it's missing. So A is 1 because A always comes from the squared term. This particular one, like there's no X. And so that's what's missing. So that is our B term. So we're going to use 0 because it's missing. It's gone. And then the C is the -9. So opposite of B is still 0. Opposite of 0 is always 0. Plug it in. 0 squared minus 4 times 1 times -9 all over 2 times 1. Now you can put those zeros in or not in the calculator, it won't care. If you want to just be consistent, just put them in. That way you don't have to think about putting them in, not putting them in. So I did go ahead and put them in just to be that consistent, always doing it the same every time.
You know if they're doing the food thing across the way?
So it's 3. And then I'm going to go do the negative 1. And it's -3. Now that problem can be done differently, as all of these can. Remember, you can factor. That one in particular can even be just done with algebra. So don't feel like you have to do them this way. I just thought this was the way you were seeming to like when you came to the office. Okay. So A is 5. B is 8. C is 4.
No, I can find the mark too.
So X is opposite of 8. B squared minus 4 times 5 times 4 all over 2 times A. So I got -0.8 plus 0.4J. Of course, we're going to put a minus under there because it's a J, which means they're in pairs. So we can just always tag on a minus. So I have 2 answers, one with a plus in the middle and one with a minus in the middle. A is 3. B is 20, C is 32. Opposite of B plus square root of B squared minus 4 times 3 times 32 all over 2 times 3. So I got -8/3 for one answer. We go grab the minus. And I got -4. Okay, last one of these. A is 3. B is -39. C is 90. Opposite of B would be a positive 39. Square root of -39 squared minus 4 times 3 times 90. 2 times 3.
You said double for all of you guys. You all 18, right?
So there's the plug one there. So I got 10 and 3.
So if they decide to shop the place, I'm going back to pay you. Are you sure?
Okay, so we the story problems now, so we'll run through those, try and set up what we can do for scenarios, and hopefully see if we can figure that out. The idea that I have though is when you do take your test, if you do get stuck, at least show me what you can figure out. Draw me a picture, try something, and leave it on there, so I can at least see what you have done. Which also reminds me, when you do take your test, I do want to see your work. So if you don't want to show it on the computer, if it's not working, like you said on the quiz wasn't working, what you can do is take pictures of your work and then just send them to my email, and I can look at them through the email. So, okay, a hole in the side of the large metal tank needs to be repaired. A piece of rectangular sheet metal, so I'm going to draw a rectangle, has an area of 16 square feet. And then we're going to patch with that. If the length of the sheet metal must be 8 feet longer. So the math that longer entails is always a plus. So one side's going to be a variable. You can pick any letter you want. I tend to do X just because it's easier if I always use X. The other one is 8 feet longer, so it's that amount plus 8. Now area is always length times width. They told us the area was 16. And then with the length times the width, we're just going to multiply these two side lengths. So x and x plus 8. So in order to solve this, we do have to do the distributive property first. So x squared plus 8x. And then we can't solve it unless it's equal to 0. So I'm going to minus 16. So 0 equals x squared plus 8x minus 16. So A is 1, B is 8, C is negative 16. So I'm going to go ahead and plug it into my formula. So opposite of B, square root, B squared minus 4 times A times C, all over 2 times A. So for one answer, I got 1.66 approximately. That's rounded. I forgot to show you my plugin, sorry. Now I'm going to do the minus. And I have a negative 9.66. Now these are the answers that fit this quadratic equation, but we have to think that we're doing a situation in life, and we have to make what fits the situation. So in our case, we're doing the side lengths of a rectangle, and there's no way we're going to have a negative side length. I'm not going to say go measure that rectangle and it's a negative 9 units. So we're going to cross that out, which means our 1.66 is our answer. So x is 1.66 feet. Sorry. And then this other one is 1.66 plus 8. Which is 9.66 feet. So our answers our dimensions are a 1.66 by a 9.66.
You gotta shake it out. I told him he wasn't.
Okay, number 3's type of story problem. A variable electrical current is given by I equals t squared minus 7t plus 12, where t is in seconds. At what times is the current equal to 3 amps? Current is measured in amps. So this 3 is our current. That is our current. So we're plugging it into I. So we get 3 equals t squared minus 7t plus 12. So if you see a similar type of problem, it always starts by taking the number they give you and plugging it into the equation.
Keep your eye on him.
So 1 minus 3, 0 equals t squared minus 7t plus 9. So our A is 1, our B is negative 7, and our C is 9. So it's a T, so I'll go ahead and use T. Be no different than using X, though. So opposite of B would be 7 plus the square root, negative 7 squared minus 4 times A times C, all over 2 times A. Sorry, I accidentally put something in wrong. Have to fix it. So I plugged it in, and the first answer I got was 5.30. I'm going to do it again. Subtracting. And it's 1.70. So these are positives. So we have 2 answers, and the reason we have 2 answers is it's a variable current, which means it's ebbing and flowing. It's going up and down, which you probably know all about because you're of your profession. So we have one at 1.7 seconds and one at 5.3 seconds. So sometimes we will have 2 positive answers. Sometimes we'll have a positive and a negative, and we'll throw out the negative. So it just depends on the scenario. Okay? Okay, number 4. Rectangle. So one side of a rectangle is 5 centimeters more than another. So one is x, one is x plus 5. Area is 204. So we're going to plug that into the area formula like we did in number 2. Area equals length times width. So 204 equals these 2 multiplied. It doesn't really matter what order you put them in. I tend to put the x in front. Just makes it easier, I feel like, to distribute. So I get x squared plus 5x minus 204. So 0 equals x squared plus 5x minus 204. So A is 1, B is 5, C equals negative 204. So we're going to plug that in. I'm kind of out of room, so I'll show you how I have it on my calculator. So opposite of B plus the square root of B squared minus 4 times A times C over 2 times A. So there's my plug-in. So that's 12. And then I'll do the subtraction one. And I got a negative 17. So I ended up with a negative amount again, but it's a distance, so I can't have that. So I'm going to throw that away. So that means my x is 12. So this side is 12 right here. And then this is x plus 5, so it's 12 plus 5, which means my other side is 17 centimeters. So it's a 12 centimeter by 17 centimeter rectangle that we need. Okay, moving on to graphing. Vertex is either the lowest point or the highest point, so we got to get to the graph. So here we are on our calculator, and we have the escape button, and then right below it we have the little picture of a calculator. We're going to click on that, and then I have a picture. So I don't know what's on my calculator, so I'm going to go ahead and I'm going to delete that. I just come down to the delete button, which is actually on the other side here, below the menu button. Hit that 3 times, and it'll ask you, are you sure you want to delete? I'm just going to tell it yes. So I should have a nice plain screen at that point. Okay, in order to plug in your equation, you have to hit the tab button. So escape, the little calculator, then the tab button is right here, so we're going to click that. On my calculator, it shows up on the top where it says F1 of X. Yours could be on the top or on the bottom, it doesn't matter. Just need to have one of them. And we only plug in after the equal sign, so we're going to start at the 4. Now your variables, so all of your alphabets down here at the bottom, it is actually alphabetical, and the X is down here in one of these 3 gray buttons. It's just X, Y, and Z. So go ahead and click X, then hit squared, minus 12, hit X again, plus 9. Once you have that in, you just go ahead and hit enter. Okay. So the spot we're looking for when it talks about the vertex, since our graph is opening up, we want the very, very lowest spot on the graph. So we're going to just count our little lines to get to that point. If you happen to do a problem where your graph is opening this direction instead, the vertex would be the highest point. But in our case, since it's opening up, it's the lowest point. So use the little dashes on your calculator. I have a little 0.5, so it says there each dash is 0.5. So I'm going to count over 1, 2, 3 dashes. So that's 1.5. So on the x-axis, that point is 1.5. And then because it's directly on the x-axis, I'm moving up and down. My y variable is 0. So if it wasn't directly on the axis and you had to go up, you would just count how many up and put that number in, or count that many down and put the number in. Okay, express in terms of j. So in this case, I have a negative under the square root, which is not possible mathematically. You can't multiply anything by itself and get a negative, so that's why this j has come about. So we're going to just plug that in, but I got to get back to my calculator first. So right now we're in the graph, right? So go back to escape, and then that little tiny calculator, push it again, takes you back to here. So we're going to do square root of negative 168 and hit enter. My calculator clicked up, gave me 12.9614 blah 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 I. Okay, so 2 things. One, it asks us to round to 3 significant digits, so I'm going to just start on the left and count in 3 numbers. So the 9 is the 3rd significant digit, but I have to use rounding rules. 6 says to move a 9 up to the next number, but if you move a 9 up to the next number, it becomes 10. So it's also moving the 2 up. So those are both going to move up, and so it's going to be 13.0. And we don't ever use I because I stands for current. So we have 13.0J. Okay, number 7. We're taking the J and we're doing it to the power of 31. So again, this calculator uses I, which is fine. That's what they use in the theory world. So the I is all the way down here at the bottom. There's a little button second from the bottom, which has a little pi button. So click on it, and you should get this little screen. And not right next to the pi is the I. So arrow over 1, and you'll have the I. So then just hit enter. And then you need your power button. So the power button is not the square button, it's the one next to it that looks like an arrow pointing up. So click on that, and then type in 31, and it gives you that. So what it's telling you is if you multiplied in your calculator j times j times j times j, and you did that 31 times, you would end up with a negative j, thanks to the pattern. Okay, we're getting there, almost there. So now what we're doing is we're moving into the little bit of geometry that we've covered so far. So here we're just asked to, what kind of angles are these? So if we have the little square in the corner of the angle, that is always a right angle. Angles that are bigger than 90 but less than 180 are always obtuse angles. Angles that are less than 90 but bigger than 0 are always acute angles. Okay, now we're going to use different rules that are out there for when I have parallel lines cut by a transversal. The transversal is T. It's the line that's cutting through those parallel lines. So it tells us that angle 6 is 121. Now that tells us a lot of things. Angles that are directly across from each other are always equal. So if 6 is 121, then 7 is 121. Also what we have is corresponding. So angle 6 corresponds to angle 2. And what that means, in my brain, I always think of it as like an intersection and what houses are in the same location. So angle 6 is in the upper right and angle 2 is in the upper right. So they're in the same location, so they're equal. And because 2 and 3 are directly across, angle 3 is also 121. Now, angle 6 and angle 8, they form this straight line. Angles that form a straight line equal 180. So we know that 121 plus angle 8 equals 180 degrees. So to figure out what angle 8 is, we just have to minus 121 to figure out what is that other part that I need to get to 180. So 180 minus 121 is 59 degrees. So angle 8 is 59. Since angle 8 is directly across from angle 5 is also 59. Angle 8 is in the same location as angle 4. It's in the bottom right, so it's also 59. And it is directly across from 1, so it is also 59. So it asks us for angle 1, which we've determined is 59. Angle 2, which we said was 121. And angle 8, which we said was 59. Now we're going to do a similar thing on a much larger scale here on the next one. Okay, so let's see what we know. We have lots of stuff here. So 78 is directly across from this empty one, so this is 78. 44 is directly across from here, so this is 44. And really we have a straight line there. So I've created this straight line, which means that 78 plus F plus 44 equals 180. So when I add 78 and 44, that's 122. So 122 plus F equals 180. So I'm going to take away the 122 to see how many degrees are left to go for F. So that is 58 degrees. So F is 58. Okay. Now let's see what else we know. Because I have a straight line here on this line, and this is 90, that means the other side has to also be 90. So 64 plus E have to equal 90. So if I minus 64, then E is going to be equal to, nope, 26. It's a 2. It's a really bad 2, but it's a 2. Yep. So angle E is 26 degrees. Now we're going to go back to the idea of these parallel lines. So I have a parallel line here and a parallel line here being cut by this transversal. So things that are in the same location are going to be equal. So 78 here is in this bottom left of the intersection. So if I go down to this intersection, the bottom left is angle B. So this is 78 as well. And then 78 and A make a straight line. So 78 plus A equals 180. So minus 78. So A is 102. Okay, now I need to switch over to this other transversal. So I still have parallel line, but this is my transversal this time. So same positions. Angle C in this intersection, which would be bottom right, is in the same location as F. So if F is 58, then C is 58. And then we have a straight line now. So D plus 58 has to equal 180. So I'm going to minus 58. And so D equals 122. Okay, so I think that's it on that one. So we just have one small piece left. That's just these shapes. Okay, so we just have these shapes left, depending on how many sides they have on what we call them. So this first one has 5 sides, so that is a pentagon. This next one, and I'm just going to use a mark to know what side I started counting on. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has 9 sides, so it's a nonagon. This one has 3 sides, so it's a triangle. This one has 1, 2, 3, 4, 5, 6, 7, 8 sides, so it's an octagon. This one has 1, 2, 3, 4, 5, 6, 7 sides, so it's a heptagon. This one has 1, 2, 3, 4, 5, 6 sides, so it's a hexagon. This one has 4 sides, and we're being very generic. Anything that has 4 sides is a quadrilateral. So if you've ever driven a quad or ridden in a quad, just think it has 4 tires. So 4-sided shape is a quadrilateral. So, okay, so that's everything you need to know for this first exam. If you need anything else, let me know, and I'm hoping it'll help. Thank you. Bye.